Okay, for this video, what I want to do is talk to you about finding a possible rational function for a given graph, using the information in the graph to help us create a rational function that could look like this. Okay, so what we're going to start with is we're going to start with the numerator. If you remember, the numerator helps us find our x-intercepts. So our x-intercepts are at 1, 0, and 3, 0. So we know that we have x-intercepts at 1, 0, and 3, 0. And remember, we find the x-intercepts by taking our simplified form of our rational function and setting it equal to 0. So this will help us find our numerator. Okay, so basically what happens with this is the numerator for this one can be found by x equals 1, x equals 3, and then I'm going to move both of these to the other side. And so we know that we have x minus 1 and x minus 3 in some form in the numerator. Okay. The thing that we want to look at here is, at this point, does it touch or does it cross? So this point crosses, okay, and this point touches. So if you remember from polynomial functions that if it touches it, that means that the multiplicity of this has to be even. So that tells me that this has to repeat at least twice. So this one has to have a degree 2 because of the fact that it touches at that point and it does not cross. This one has to have an odd multiplicity. That means it repeats an odd number of times. So the lowest degree for that is 1. So since this says least degree, we want to go with the lowest that we have. So for our numerator, our least degree is x minus 1 squared, and then we have x minus 3 to the first power for this point right here. Okay, so now we have a potential numerator. Okay, there could be other numerators because things could have canceled out to start with, things of that nature, but we're going with the easiest one that we can find. So what we want to look at next is we want to look at our denominator. Okay, so we have a couple other things that I'm going to discuss in a second, but the denominator, remember that this helps us find our vertical asymptotes. Okay, so the denominator comes from our vertical asymptotes. This one does not show us any holes, so we can't say that there's any holes in the graph. So we're just going to look at our vertical asymptotes to help us find our denominator. Okay, so with this, what we have is we have a vertical asymptote at x equals -1, and we have one at x equals 2, which tells us that we started with x plus 1 and x minus 2 as our functions, because if we take this over to the other side, that gives us what we had in the parentheses. Okay, so we want to look at a couple different things here to help us determine the degree of this. One of the things that we must know is that because we have a horizontal asymptote at y equals -1, that tells us that the ratio of our values, that number one, it tells us that the degree of our numerator and the degree of our denominator have to be equal. And then the ratio, or the number in front, the numbers in front of our leading coefficients have to simplify to be -1. So we're going to talk about that in a second for the next one, but we need for sure our numerator and our denominator to have the same degree. So if you look at this right now, our numerator has a degree 2 and 1, so that's 3, and this only has 2. So we know that we have to add something else to this. So far we have f of x equals x minus 1 squared over x minus 3, because this tells us that we would have x-intercepts at 1 and 3, which we have, and this one repeats twice, which means that our graph touches, so that helps us find that. And then our denominator, we know that we have to have an x plus 1 and we have to have an x minus 2, but we need to talk about the degree, because right now this is degree 3, this is only degree 2, so one of these has to have an even multiplicity. So the way that you tell whether it has an even or an odd multiplicity is you're going to look at the horizontal asymptote and you're going to look at the vertical asymptote. So since we have a vertical asymptote here and a horizontal asymptote here, if I look at my two graphs, they are on opposite sides of my horizontal asymptote. So if I look on these, they're on opposite sides, they're across from each other, which tells me that this one has to have odd multiplicity. So the x equals -1 has to have odd multiplicity, so we're going to leave this as a degree 1. Okay, for this one, if you guys notice, when I look at this one, if I extend my horizontal asymptote out, my horizontal asymptote, these two graphs are on the same side of my horizontal asymptote. So if they're on the same side, that tells me that the multiplicity has to be even. So if they're on the same side, okay, it tells us that it has to be even multiplicity. Okay, so that tells me that this one has to repeat an even number of times, so it has to be squared. And now if we look at it, we have 3 on the bottom, 3 on the top, so we have even degree for the numerator and the denominator. And then our last step is that we have to get it to have a ratio of -1. Right now my leading coefficient would be x cubed and x cubed, so it would just be 1/1. So I need to add a negative to this somewhere. So I could just put a -1 in front here, and that would make it so that the leading coefficient would have a ratio of -1, which would give me a horizontal asymptote at -1. So the equation or the function f of x equals -1 times x minus 1 squared times x minus 3 all over x plus 1 times x minus 2 squared gives us a possible rational function for this graph. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well.